Good morning, fifth grade. This is Miss Allen, and today we're going to be doing lesson 16. So our standard for today is MGSE NF6, which is solving real world problems by multiplying fractions and mixed numbers. Our I can statement is I can multiply fractions in word problems. And the vocabulary that we will be using today are fractions, numerator, denominator, area model, number line, and equation. Okay, so let's start out with looking at our first example. We have to study the example problem showing 3 ways to model multiplying fractions, then solve problems 1 through 6. For number 1, it says, what is 2/3 times 3/5? So you can find 2/3 times 3/5 by using different models. The first model is a number line, and it shows 2/3 times 3/5 by shading in 2/5. So as you can see, you see the first 1/5, and 2/5. So 2/5 is shaded in. The area model shows 6 out of 15 total because we have 1, 2, 3, 4, 5, 6 that's shaded in out of the total 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So you have 6/15 here. The last one is our equation, which shows multiplying the numerator by the denominator. 2 times 3 equals 6, and 3 times 5 equals 15. Okay, so I went ahead and showed you how 2/5, which is on the number line, can be converted into 6/15. What you would do is you would multiply both the numerator and the denominator by 3. So if you start with the denominator, if you multiply the denominator by 3, 5 times 3 is 15. So whatever you do to the denominator, you have to do to the numerator. You multiply 2 times 3 and you will get 6. And it's the same thing as 6/15. So for the number line, you get 2/5. The area model is 6/15. And the equation is 6/15. And to convert 2/5, which is the number line, to 6/15, you multiply both the numerator and the denominator by 3. Okay, so moving on, we're going to look at number 1. It says, look at the example showing the models of 2/3 times 3/5. How are the models alike and how are the models different? So we are comparing between the number line, the equation, and the area model. So it looks as though all 3 models show the parts of the problem, the factors, and the product. So the area model shows the different quantities, the number line represents them with pictures and numbers, and the equation represents them with just numbers. So for the number line and the area model, you need to interpret the product and write the numbers to represent what is shown, while the equation shows it already as a number value. For number 2, it says write the product for 2/3 times 3/5 shown by each model in the example. So as we can see, for the number line, we got 2/5, 1/5, 2/5. So that's 2/5 for the number line that you would write in. So I would write in 2/5 for the number line. For the area model, I would put in 6/15. And for the equation, I would also put in 6/15. Okay, so now we're going to move on to number 3. We're going to solve. Write the missing numbers that show that 2/5 and 6/15 are equivalent fractions. So just going by what I showed you earlier in converting 2/5 to 6/15, we would just multiply the numerator and denominator by 3, which would give us 6/15. Number 4, it says, explain how the numbers you wrote in problem 3 show that 2/5 and 6/15 are equivalent. So, since you can multiply both the numerator and the denominator of 2/5 by the same number, which is 3, to get 6/15, it means that 2/5 and 6/15 are equivalent because it is the same as multiplying 2/5 by 1, which is 3 out of 3. Okay? Okay, so for number 5, it says, what is 2/3 times 3/8? Show your work. Okay, so when showing our work, we would multiply 2/3 times 3/8. We multiply our numerator first. 2 times 3, we get 6. 3 times 8, we get 24. So our solution here is 6/24. And it says number 6, check your answer to problem 5 by modeling 3/8 in a different way. So what we could do is we could use the area model. Use my tool here. And I can model first. I'm going to make 24 blocks. 1, 2, 3, 4, 5, 6, and then just do one more. 7. So that'll give me a total of 1, 2, 3, 4, 5, 6, 7, 8. And this gives me 8, 16, 24. So if I'm modeling by 2/3, I'm going to shade in 2/3 here. And if I'm modeling 3/8, I'm going to shade in 3/8 here. Okay, so for my 2/3, I've shaded in 1, 2 out of 3. For my 3/8, okay, 3/8 goes on the top. I've shaded in 1, 2, 3 out of 8. I'm sorry, this should not be shaded in, just this 1, 2, 3 out of 8. So I'm going to actually erase the 4th one. Got a little too happy with that. So I'm just going to erase that. Okay, and so this shows 1, 2, 3, 4, 5, 6 out of a total of 24 boxes. So you have 6 out of 24. Okay, our next page asks us to study the example with the problem showing one way to solve a word problem with fractions. Our first example is Vicky's favorite beach towel is green and white and has a fish design. The green part covers 5/8 of the towel. A fish design is drawn on 3/5 of that. What part of the towel has the fish design on it? So the first thing we're going to do is draw a picture. It says show a towel with 5/8 shaded green and draw fish on 3/5 of that green part. 3 of the 8 parts of the towel have fish drawn on them. So 3/8 of the towel has a fish design on it. You can also write an equation to solve the example problem. Write the numbers to complete the equation showing what part of the towel has the fish design. So 3/5 out of 5/8 means 3/5 times 5/8. So we can model that by saying, using our tools, that 3/5 times 5/8 equals 5/8 times 3/5. So in this first blank, it's going to be 5/8. In the second blank, it'll be 3/5. Okay, and if we multiply 3 times 5, we would get 15. and 5 times 8 would be 40. So our answer would be 15/40. Number 2, it says, is your answer to problem 1 the same answer as the 3/8 shown in the example problem, and explain? And it says, yeah, and our answer will be yes, 15/40 is equivalent to 3/8 because 3/8 times 5 over 5 would equal 15/40. So basically saying that if we multiply 3/8, which is our answer, if we multiply the numerator and denominator by 5, we would get 3 times 5 would be 15, and 8 times 5 would be 40. Okay, so 3/8 and 15/40 is equivalent. All right. Okay, so for number 3, it says, suppose the green part of Vicky's towel covers 4/5 of the towel, and the fish design is drawn on 3/4 of that. Draw a picture to find the part of the towel that has the fish design on it. Then write the answer. So what we're doing is we're actually solving a problem that's similar to our example. So what we would do is we would make we're going to make a towel. So we're making Vicky's towel, and it says the green part of Vicky's towel covers 4/5 of the towel. So we're going to break the towel into 5 parts. 1, 2, 3, 4, and that's 5 parts. 1, 2, 3, 4, 5. So now it says the green part of her towel covers 4/5. I'm going to shade in the green part. This is the green, 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 green. That's shaded in. And then it says the fish design is on 3/4 of that. So this I'll make one fish. I'll just make a F for fish. Here's one fish here, one fish here, and then one fish here. Okay. And it says, then we're writing the answer. So let's see what our solution would be. If we were to multiply 4/5 times 3/4, our answer would be 4 times 3 would give us 12. 5 times 4 would give us 20. So our answer would be 12/20, but if we reduce it to the simplest term, we could divide both sides by 4 because that's our greatest common factor, and our answer would be 3. 12 divided by 4 would be 3. 20 divided by 4 would be 5. So our final answer would be 3/5. Okay? All right, our next problem, or number 4, asks us to write an equation to show the answer to problem 3. And so actually I just did that, and I just erased it. So that problem that I just put, which was 3/4 times 4/5 was 12/20. All right, and when I reduced that down, I divided both sides by 4. 12 divided by 4, I got 3, and 20 divided by 4, I got 5. So for number 4, this is our equation. 3/4 times 4/5 equals 12/20. Our solution is 12/20 or 3/5. All right. Okay, last question that we're going to work on is number 5. At noon, Ada and Kent had 3/8 gallons of gallons of lemonade left at their lemonade stand. The next customer bought 1/3 of the remaining lemonade. How much lemonade did the customer buy? And we want to make sure that we show our work. Okay, so what we would do is I'm actually going to show you using an equation. So